Okay, it looks like it's good. Let's see, calculate anything, remember, do not round. Okay. The total area of a normal distribution curve must equal, is that 1?
I think it's, yeah, just one whole.
So 1, okay. Under certain circumstances, a normal distribution curve can drop below the x-axis. I don't think that's true.
Yeah.
False. Okay. A normal distribution curve is symmetric.
It's true.
It's true. Which of the following elements of the figure represents the z-score? Is that C?
Hmm.
I think I still have that up.
Yeah, I think it's the curve to the right.
Okay. That's what I was thinking. So C?
Yeah.
Yeah, that number right there.
Mm-hmm.
And which of the following elements of the figure represents the probability that the z-score will be greater than 1,000? Potentially B, but it might be none of them.
Yeah.
I don't know with that phrasing. Let me see if there's anything in the textbook. I think it's B.
Yeah.
That is like a weird question.
I'm just not sure because I know you can like use that number to find the probability, but I don't know if that's exactly what that section is.
Yeah.
Oh yeah, greater than 1. Yeah, that would be B. Yeah.
Okay. I guess we can go with it for now because if it's not B, then I'm sure it's none of them. So then we could do the next one. According to the 68, 95, 99.7 rule, what percentage of the data from a bell-shaped distribution will be within 1 standard deviation of the mean? That should be 68, right? 1 is 68.
Yeah.
Okay. Suppose that z-scores come from a standard normal distribution. Use normal probability applet to answer this question. What proportion of the z-scores will be between -1 and 1?
That one would be 90.
So,
or are we still actually?
So we're just using the numbers that it pulled up automatically, right?
Yeah.
So then I got 0.6827.
Yeah.
All right. Accurate to 3 decimal places, so 1 less than that. So 683. Okay, that just seems weird. I guess that must just be like a perfect normal distribution. Suppose that z-scores come from a standard normal distribution. Use the normal probability applet to answer this question. What proportion of the z-scores will be between -2 and 2? So if you change the z-score to 2 and -2, then the area is 0.9545. So 0.955.
Yep.
All right, and what proportion of the z-scores will be between -3 and 3? That's 99.7. Well, 0.997, I think is how as you enter it.
Yeah. that round.
Okay, what did you deserve? The values match the 68, 95, 99.7 rule.
Yep.
Okay, so what proportion of the population have a protein requirement that is less than 0.6? What's the best way to do that? So do we have to find the z-score first and then convert that to a probability?
I think that's what it talked about in the
In that video? Yeah, I think there was one. I just don't remember. Let me see. Let's see. So you do the 0.6. I guess I could just do it in a calculator.
0.6 minus the mean, and then
0.6 minus 0.65.
divide it by.
What do we divide it by? By the standard deviation,
Yeah.
which is 0.07. So I got negative 0.714. Is that what you guys got? Wait, but then that's just the z-score.
yeah.
And then what did we do next? I don't remember. Not percentiles, right?
Mm,
Or is you say a proportion of the population? Is that asking for the percentile?
Let's see. I think it's. I think we have to put it into the applet, and then we see.
So
Then the
just like,
proportion.
let's see, it's negative. So do we put it on the left side? Just do negative 4. And then it would be like 0.5248.
Yeah, I think so. I don't know. This one's kind of.
I'm just not 100% sure what it's asking.
Yeah, I'm not the best at this one.
I don't know. I say we go with it, I guess, for now.
Yeah.
See if we get it right. And then what proportion of the population have a protein requirement that is more than 0.6? So I don't know how to do that because then it's just going to give us 0.
Mm-hmm.
Oh, wait, no, it doesn't. Let me see. 0.65. So it should be the same z-score, right? But it's just to the right instead of in the middle.
Mm-hmm.
Okay, I was doing it backwards. So then it's the 0.238.
Yeah.
And what proportion has a protein requirement that is less than 0.7? So then go back. And then that's the z-score. Did you guys get 0.7624?
Yeah.
Okay. Okay. A randomly selected person will have a protein requirement that is between 0.6 and 0.7. Okay, so do we need to find the z-score of each one then first? Yeah. Okay, so 0.6.
Are we using the same mean for this one from the last question?
I think so. So it's still just the negative 714 and the positive 714. And then it's just between them, right? The hint is confusing me. Do we even need to do that, or can we just click in the middle? Because that would just be that 5248 again.
Yeah.
I think in the book you have to find both, but that seems right.
Mm-hmm.
We can just try that, I guess.
Because if we shade to the left of each z-score, yeah, that's gotta be it.
So 0.524.
Yeah. Except it would round to 525, but
Mhm.
yeah. Okay, and then find the 35th percentile for the protein requirement for adults. Okay, so that's that other equation that they gave us, right? Where we solve for x instead of for z.
Yeah.
Okay, so it's going to be the mean, which is 0.65 plus the z-score. So what is it, the z-score of 0.65?
The z-score?
Yeah. Because we're doing that other equation that's the x equals the funky u plus the z-score times the standard deviation, right? But I don't know what the z-score we're using is.
I think it's the, let's see. I think I did it wrong. I bet we just use the same one. So that would be anything.
That 0.714?
Yeah.
Yeah.
And then the 0.65 would be just the
Let's see, and then what was the standard deviation?
population.
Well, let's do that and see if it makes sense. So that'd be 0.699. But the 35th percentile should be less than the mean, right?
Yeah.
Yeah. So that wouldn't work. Let's see. Okay. And then,
Let me see if I can just open up that video again because it made sense at the time. Now my video doesn't want to play. There we go. That's what it was. Okay. So you go into the applet and you shade the left side. And then you click on the area instead of the z-scores and you put in 0.4.
oh,
That's why. And then what?
okay.
Okay, so then in that app, the z-score on the left is the one that we use and put in that equation.
So
So it
what
should
are we
be
using for the z-score? Are we using the 0.6 or are we sub-zero or
the
the same one?
negative 0.253 is the z-score.
Okay.
And then you still multiply it by the standard deviation, and the 0.65 was the mean. Oh wait, except for it wasn't, I put in 40th percentile because that's what he was doing, but it's 35th percentile, huh? So that changes it a little bit. Negative 0.385. Is that it? So then I would have 0.623. Is that what you guys got?
Yeah, that sounds a little better.
Because it should be under, I mean, that's a little bit under the mean, so it makes sense.
Now the 80th percentile.
Okay, and then it was different if it was over 50%. So I'm gonna keep watching the video. Okay, so then the difference when you do over 50% is you click the middle section and the left section, and then the z-score is the far right bar instead of the left one.
Hmm.
And the area would be 0.8.
That seems right.
So 0.842 is that z-score. So then it would be 0.709 would be the 80th percentile.
But like then the reading seems a lot easier than once you're actually like doing it and stuff. It's like so confusing.
I know, they're like, what? Okay, so that was the last question. So we go ahead and submit it. See how we did. We got a 90%. So we got the 2 wrong. That converting the percentiles. The ones that have less than 60 and more than 60. You guys have any ideas how to do that one right?
Wait, which one was it?
Questions 13 and 14.
Oh, I got those ones right.
Really?
Oh, what did you answer?
I got 0.238 for the first one and 0.762 for 14.
0.238 and 0.762.
Yeah.
What on earth did I do? I think I might have just put the 238 in the wrong spot.
Yeah, I thought that we had figured those ones out. Because I got
Maybe
those
we
right.
did, and I just entered them wrong.
Yeah.
Wait, so 0.238 for 13, and then 14 was what?
0.762.
It looks like I got 15 wrong too. What did you guys have for 15?
For 15, I had 0.762. What did you have for 15, Brandon?
Yeah, that's what I had.
So you had 0.762 for both 14 and 15, and they were both right?
Yeah.
Weird.
I got
What?
8 wrong too.
8? Let me see. 8, I said 68.
68, yeah.
Oh, I put a point instead.
Oh, you just did 0.68. What on earth? Okay. See if we can all get it this time. 4 was false, 5 was true. Okay, so then 13 was 0.238. What were 14 and 15 asking? One was more than 60 and the other one was less than 70, and they just happen to be exactly the same. That's so weird.
Mm-hmm.
All right, there we go. I got 100% that time. I guess I could stop the recording. We're done, really.
Yeah.